We are going through exercise 18e, and in this video I'm going to be answering question 11, which says let f be this, find the absolute maximum and the absolute minimum. The word absolute here, absolute, is going to be very important as we go on. Okay, so what's the first thing we're going to do? The first thing that we're going to do is give our graph a sketch. That's what we're going to do. We're going to sketch it. So let's see what we have been given. We have been given f of x is equal to 2x cubed minus 6x squared. And we also have a restricted domain here, 0 to 4. Now that's going to be very important as well and really factor into the fact that we have absolute max and mins. So the fact that we have a restricted domain and absolute max and absolute min being a part of our question, they're all tied together. But we're getting ahead of ourselves. Let's just give this thing a graph. So it's f of x is equal to 2x cubed minus 6x squared. So I know that that's just a cubic. So if I want to graph the cubic, the first thing that I'm going to do is let me just rewrite it. So it's going to be f of x is equal to 2x cubed minus 6x squared. Now, what I want to do is find my x-intercepts. That's going to be really helpful, crucial in sketching what this is going to be. So let's see if we can find what my x-intercepts are going to be. To do that, I'm going to set this equal to 0 and then try to factor this. Well, I can take 2x squared out as a common factor, and that means I'm going to be left with x minus 3. Then what I can do is, using my null factor theorem, just say set this equal to 0. So I'm going to set each of them equal to 0. So 2x squared is equal to 0. Or I can set this one equal to 0. X minus 3 is equal to 0. Now I just need to solve both of these for x. So this one's going to be x is equal to 0. And this one will be x is equal to 3. So I've just found my two x-intercepts. They're going to be 0, 0. And they're going to be 3, 0. Now, what do you notice that is a bit odd here? Well, I'm dealing with a cubic, and if we can picture a cubic for a moment, your typical cubic is going to look like this, up, down, up, and we know it's going to go up, down, up, because I have a positive in front of my, actually, let me go up here and put the positive. I have a positive in front of my x cubed term, so I know it's going to look like that. But if we look at this, you can see I have 1, 2, 3, intercepts, but here I only have 2. So what's going on there? Well, as we've seen when we were learning how to draw cubics, let me get rid of this. What we know is that when I have a term that is squared, it's going to bounce at that point. So because 2x squared is bounce, and when I solved that for my x-intercept, it was 0, 0, I know it's going to bounce at this point. And that's why I've only got 2 x-intercepts, because it's bouncing at that point. So let us now transfer this information onto our graph. So our intercepts are going to be here at 0, 0. And my other intercept is going to be, let's just put it all the way over here, at 3, 0. And let me just make sure I put this somewhere good. 3, 0, just like that. Okay, let's see if we can graph this now. So we're going to go up, 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 up. It's going to touch here. Then it's going to come down. Actually, let's see if we can draw that again. That isn't too good, is it? It's going to do this. Then it's doing this. Then it's coming back up. This is a horrible, horrible graph, but it's going to do for our purposes. Okay, so that's what it is. Not the greatest graph in the world, but we're just going to leave it there. There are x-intercepts. This is generally what it's going to look like. We also need to put in some very, very crucial information, and that's the fact that it has a restricted domain between 0 and 4. So let's put in that information, the fact that it has a restricted domain. So that means I'm going to go from 0, so right here, to 4. Let's say 4 is over here. So that means, what does that mean? This part of my graph isn't going to exist, and this part of my graph isn't going to exist. So it's going to stop here. So this is what my graph is going to look like. Now let's just kind of take note of some interesting things right here. The first interesting thing is, let's just label our stationary points. I'm going to have a stationary point here. This is going to be a stationary point, so let me just label that. That is going to be a stationary point, so meaning the gradient at that point is going to be 0. I'm going to also have another stationary point here, because if you remember what our graph looked like, that was a stationary point. It might not look like it anymore because we've gotten rid of that section, but it is. This is a stationary point. So we know something about these points. We know that the derivative is going to be equal to 0 because the gradient is equal to 0. Now, what else can we identify? Well, we can identify what this is right here. This right here is going to be my absolute maximum. And let's have a chat as to why that is the case. It's nothing too complicated why. It's my absolute maximum because it's the highest y value in this entire graph. So remember, well, let's call this f of x. And x, it has the greatest f of x value. So that's why it's the absolute max. And we can find what this is going to be. It's going to be 4, because there's a 4 here. And to find what my y is going to be, I simply sub that 4 into my f of x. So let's scroll down here and let's go f of x is equal to, now I don't know what it is. What is my f of x? It's 2x cubed minus 6x squared. 2x cubed, 2x cubed minus 6x squared. That is what it's going to be. So now let's figure out what I'm going to get. I'm going to get 264 minus, this is going to be 6, it's 416. This is going to be 128, and this is going to be 96. So I'm going to be left with 32. 32. So when I sub x equals 4 in, I get 32 out, which means the absolute maximum for this graph is going to be 4 and 32. Now, if we go up here for a second, that's actually one of the parts of the question. We've just answered half this question because it asked us to find the absolute maximum. So would you look at that? We have found half of this question. Now, what's my absolute minimum going to be? Well, my absolute minimum is going to give me the lowest f of x value, and that's going to be this point right here. So it's a stationary point as well. This is going to be my absolute minimum. So let's write that in. It's going to be my absolute minimum. Okay, and we've also got this point right here. It's another stationary point. What we would call this is a local maximum. So it isn't my absolute maximum, absolute being the maximum of the whole thing. It's just a local maximum. In this general region right here, it's a maximum. It's a local maximum, like your local leader. It's a local maximum. Okay, so in order to answer this question, we've found half of it. We've found what the absolute max is 4 over 32, but now we need to find what the absolute minimum is. And the way that we're going to do that is by taking advantage of the fact that this is a stationary point. We can use this to our own advantage because a stationary point has a certain characteristic, namely the derivative is equal to 0. So let us do that now. So let's come over here and let's do some calculus. So this is our function. What I'm going to do is differentiate it, which means I'm going to get, let's get a thinner pen. It's going to be f dash x is going to be equal to, it's going to be 6x squared minus 12x. So that's going to be the derivative. Now I need to find what my stationary points are going to be. How do I find the stationary points? Well, what I do is, to find the stationary points, let f dash x equal 0 and solve for x. So that's knowing that my gradient is equal to 0. So the derivative is equal to 0 and I'm solving for x. So let's now do that. So I'm going to go 0 is equal to, and I'm going to factorize this so I can take 6x out, which is going to leave me with x minus 2 equals. And now what I can do is say, well, let's set each of these equal to 0. So I'm going to get 6x is equal to 0, or x minus 2, oh, that's not a minus. X minus 2 is equal to 0. Let's come down. So I'm going to get x is equal to 0 and x is equal to 2. So these are my stationary points. Now remember, I'm trying to find when I have a minimum, right? So if we zoom out for a second and really just appreciate this, obviously, having graphed it, we know that this is going to be x equals 2. I know that this is going to be, if I was to put it in green, to keep the colors the same, it's going to be 2 something y. And when x is 0, I know it's obviously over here because we've graphed it, we know. So x of 0 is going to be my maximum, and x equals 2, x of 0 is going to be my maximum, x equals 2 is going to be my minimum. But let's just prove this. Let's go through the steps of proving the nature of our stationary points. So we've just found our stationary points. Let's now find the nature of the stationary points. So we found the stationary points, now we're finding the nature of them. And in order to do this, we're going to have to make some tables. Okay, so let's go. So this is going to be x, this is going to be f dash of x, and this is going to be the shape. I'm going to put 0 here because I'm dealing with this one. So I'm going to put 0 here. That's going to have a derivative of 0. I'm going to find the derivative for when x is equal to -1, and then on the other side when x is equal to 1. If I was to do this, so I'm going to have to go f dash of x. Now I forgot what my derivative is. What is my derivative again? It is 6x, x minus 2. So it is 6x, x minus 2. So if I was to go let f of -1, f dash of x of -1, I'm going to get 6, -1, -1, -2, which is going to be equal to -6, -3, which is going to be equal to -18. So right here, this is going to be negative. Ooh, I messed that up. It's not going to be negative. It's going to be positive 18. Ooh, that would have been embarrassing. It's going to be positive 18 because a negative times a negative is positive. So this is going up. This is flat. And then I would have to sub in what's f of 1. So let's do that now. What is f of 1? F dash of 1 rather. Ooh. So I'm going to go 6, 1, 1 minus 2. So that means what I'm going to get here is 6, and then 1 minus 2 is going to be -1. So it's going to be equal to -6. So on this side, I'm going to get -6, and that's going to be down like that. So just like that, I'm able to prove that this is going to be a local maximum. So this right here, I have proved is a local max. So when x is equal to 0, I get a local max. And then I would now do the same process for x is equal to 2, find out what this is. So 2, 0, this is my x, this is f dash of x, and this is my shape. This is a long question. So what I'm going to do now is put in a point before it. So let's put in 1, let's put in 3. If I put in 1, that's going to be -6. This, therefore, is going to be a negative. I already know that. I don't have to prove it again. I know it's going to be -6. So therefore, my graph is going to be going down. Then it's going to be flat. And now let's put in f dash of 3. That's going to be 6, 3, 3 minus 2, which is going to be equal to 18. This will be 1, so this is going to be equal to 18. So that 18 is going to go here, so that's going to be positive, so it's going to go up. So this is going to be my local min. Let's try it like local min. Perfect. So we have done everything we needed to for this right now. We could find out what this is. So if I was to sub it in, I could find it what it's going to be. Should we do that? We probably should. Let's do it just for completeness sake. To find what my y value is going to be for my absolute minimum, what I would do is I would come here and I'm going to sub in f of 2 into it. So I'm going to go f of 2 is equal to, and let me just put this as f of 4 here, f of 4 here. So f of 2 is going to be 2 cubed minus 6 2 squared, which is going to be, let's zoom in here. It will be, let me give myself some more room. 2, 8 minus 6, 4, which is going to be 2 times 8 is 16, minus 6 4s are 24, which is going to, oh, I didn't mean to put that, is going to end up being -8. So I could come up here and I could say this is going to be -8. So let's note the fact that my absolute min is also my local min. And all of that can be nicely summarized in a statement like this. So you should write a statement like this. Let's have a look at it. So with all that working, x equals 0 is a local maximum. F of 0 is going to be equal to 0. And that's what we proved here. It's a local max because it's my stationary point right there. But f of 4 equals 32. So as you can see here, if we let if we sub in x equals 4, we get 32 out. So that's the absolute maximum. So what they're really saying there is when I subbed x equals 0 in, I got 0 out, but when I sub x equals 4 in, I get a greater y value out, proving that it's an absolute maximum. Well, this would just be a local maximum. And then what we're also saying is that when x equals 2, so when x equals 2, it's going to be an absolute min of, and then they're just showing it's going to be -8, which we proved as well. So there you go, quite a long question, quite an involved question. And as you can come back here now and look at the question, what I really said at the beginning is this is going to be an interesting question because we have a restricted domain and we're asked to find the absolute max and absolute min. So that really impacts things. So hopefully all this made sense. And let me zoom out. Hopefully you found all this useful. And I'll see you in the next video.